Okay, next on the agenda, we have, sorry, I just finished the last one. Graph theory. This was really fun. So graph theory is a fascinating field of mathematics that deals with graphs, mathematical structures used to model pairwise relations between objects. Graph theory provides a powerful framework for understanding relationships, analyzing networks, and solving practical problems across various domains. All right, so directed versus undirected graphs. Undirected graphs are bidirectional. You don't have to tell it, go here, go here, go here. Anytime that they're connected, it can go both ways. So that really reminds me of a network, like the internet or whatever. A network without security. Directed graphs have edges and asymmetric relationships. So some things can only go one way and not the other way. But they're efficient for modeling processes and dependencies. So like you're sending information to your printer. That's a one-way street. You're not going to have things coming back the other way you're going to have some messages go back and forth, but your printer's not going to send the paper back to you, right? There's a definite end. Like we were talking about acyclic and cyclic graphs. There's a definite end to that one. So this is all about the 7 bridges. So the problem is, I can't pronounce this guy's name. The city, now Kaliningrad, Russia. The city in Russia was situated on both sides of this river, and it included 2 large islands connected by 7 bridges. The challenge was to find a walk through the city that would cross each bridge only once. Solutions involving reaching an island or a mainland bank without using a bridge were explicitly unacceptable. So you can't take a boat and you can't jump. You're not a superhero. So Euler, the guy who was trying to solve this problem, realized that the choice of route within each landmass was irrelevant. The critical aspect was the sequence of bridges crossed. This hurts my brain, y'all. He abstracted the problem, focusing solely on the list of landmasses and the bridges connecting them. In modern terms, he replaced each landmass with a node and each bridge with a connection or an edge. And the resulting mathematical structure is a graph, which is what we mess with today. So Euler observed that whenever one enters a vertex or the landmass via the bridge, they also leave via a bridge. Duh. Except in points of the walk. So this would be an acyclic graph. If every bridge had been traversed exactly once, the number of bridges, I don't know if y'all can hear that. The number of bridges touching each landmass must be even. So you can't cross 7. I got to 6 when I tried this. That was it. However, all 4 landmasses in the original problem were touched by an odd number of bridges, one by 5 and one of the others by 3. It's kind of an impossible problem. Negative resolution. It's like a Greek tragedy. Euler proved that the problem had no solution. Like I said, I got to 6. I don't know if you can do more than that. Apparently not. Maybe you could, you could do 8 because it has to be even, right? Maybe. His work established the foundations of graph theory and demonstrated the power of abstract real-world problems into mathematical structures, which, as we know, words. I guess I didn't get to the conclusion. But as we know, as coders, almost all of our problems can be solved by math. So you'll have a good night. See you next time.